GeopByte.
Let us take the another important problem. It is like this. A body of mass 1 kg begins to move from rest under the action of a time dependent force. It is given mass of the body given 1 kilogram. The force is depending on the time. That force dependent, the time dependent force is 2t I cap plus 3t square j cap. That is the time dependent force. It is given in newtons, where I and j are the unit vectors along x and y axis. What power will be developed by the force on the time t? What is the force developed? Very simple. As you know, power developed equal to f bar dot, right, f bar dot v bar. For that we need to decide the v bar. How do you decide the v bar? As you know, the force, take note. As you know, the force F equal to ma. From this, a equal to force divided by mass. Therefore, acceleration equal to, since mass equal to 1 kg, acceleration is equal to force, that is 2t I cap plus 3t square j cap. That is acceleration. But I want velocity. As you know, the acceleration a equal to dv by dt. From this dv equal to a dt, a dt. Then v equal to integral a dt, integral a dt. V equal to integral a value is 2t I cap plus 3t square j cap, right, dt. Integrate it. V equal to 2t square by 2 plus 3t cube by 3. It is equal to t square plus t cube, right? T square I cap, t square I cap plus t cube j cap, t cube j cap. That is the velocity. Let us write the velocity v bar equal to what you got, t square I cap plus t cube j cap. Correct? No? T cube j cap. Then power. For finding the power, better write I of 2t I cap 3t square. Force equal to 2t I cap plus 3t square j cap. 3t square j cap. Then what is the power? Power P equal to f bar dot v bar. F bar is 2t I cap plus 3t square j cap dot, means multiplied by t square I cap plus t cube j cap. So here you multiply I to I, j to j, 2t into t square, 2t cube I cap plus 3t square plus t power into t power 3, 3t power 5 j cap. That is the power. That is the power. 2t cube. Look at the options. 2t cube plus 3t power 5 plus 3t power 5. 2t cube plus 3t power 5. This is t power 5. T power 5. Option D is absolutely correct. Understood clearly? Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A ball is thrown vertically downwards from a height 20 meters with initial velocity v naught. Let us mark the initial position of the ball. Let this is the ground. The ball is available at 20 meters above the ground level. This is the ball. That ball is available at a height of h equal to 20 meters with initial velocity v naught. Okay. It is colliding with the ground, loses 50% of its energy in collision and rebounds to the same height. By the time it is colliding with the ground, by the time the ball is colliding with the ground, the ball is losing 50% of its energy, but it is rebounding to same height because initially the ball is maintaining both potential energy and kinetic energy. Though 50% of energy present in the ball is losing due to collision, it is rebounding to same height means the potential energy remains same for the ball. Okay. For that, let us write the kinetic energy. What you are asked to decide the initial velocity V naught. Okay. So for that, let us decide the kinetic energy of ball while it is reaching to ground. Let that is Ke1 is equal to mgh. That is the equivalent potential energy. That means by the time the ball is falling down, it is losing potential energy mgh. That will be converted to kinetic energy plus initial kinetic energy half m v naught square. Okay. After collision, after collision, it is losing 50% of energy. That means kinetic energy divided by 2. 2. But it is rising to the, it is rebounding to the same height means must be equal to mgh. Okay. That means ke1 divided by 2 equal to mgh according to given condition. But ke1 equal to what? Mgh plus initial kinetic energy half m v naught square divided by 2 equal to mgh. From this I can write that mgh plus half m v naught square is equal to 2 mgh, or half m v naught square is equal to 2 mgh minus mgh. It is equal to mgh half m v naught square. This m is cancelled. M is cancelled. V naught square, right? Finally, it is V naught square. V naught square by 2 is equal to GH. GH. V naught square equal to 2GH, or V naught equal to root over 2 into G into H. It is equal to 2 into G value 10, H value given 20. 20 into 2, 40. 40 into 10, 400. Root over 400 is equal to 20 meter per second. That is the initial velocity of the ball. Look at the options. Option A is absolutely correct. Understood clearly? Yes. Then it is also most expected problem. I am writing this is the 5-star problem. Means this kind of problem can be repeated. Okay. Similarly, let us take the another important problem asking like this. A block of mass 10 kg moving in x direction with a constant speed 10 meter per second is subjected to a retarding force. It is given mass equal to 10 kg with initial speed, let that is initial speed is v equal to 10 meter per second, and force given in terms of displacement minus zero point 0.1 times the x. It is in joule per meter. Okay. During its travel from x equal to 20 meter to x equal to 30 meter, its final kinetic energy is, you're asked to decide final kinetic energy. For that, the initial velocity, let that is u, initial velocity u. Then what is the initial kinetic energy? Initial kinetic energy equal to half into m into u square only. U square only. It is equal to half into m given 10. U is 10 square. Simplify this value. It is equal to, so 5 into 100, 5 into 100 is equal to 500 joules. That is the initial kinetic energy. Then what is the final kinetic energy? Final kinetic energy Kf equal to initial kinetic energy plus work. Work. Right? From for that you need to decide the work. Work equal to, as you know, work equal to f into dx with integration from x equal to 20 meter to x equal to 30 meter. X equal 20 meter to x equal to 30 meter. Right? It is equal to integral 20 to 30. Look at the f value. F is minus 0.1x minus 0.1 x into dx. Now you integrate it. Integrate it. It is equal to minus 0.1 x square by 2. Apply the limits from 20 to 30. It is equal to minus 0.1 into 30 square minus 20 square divided by 2. It is equal to minus 0.1. 30 square 900 minus 20 square 400 divided by 2. It is equal to minus 0.1. 900 minus 400, 500 divided by 2. 500 divided by 2 is 250 minus 0.1 into 250. It is equal to minus 25. Minus 25 joules. Right? Then work done, final kinetic energy is what? Initial kinetic energy 500 plus work done is what? Work done is how much? Work done is minus 25. Minus 25. 500 minus 25, 475 joules. That is the answer. Look at the option A. Option A is absolutely correct. Okay. It is also most expected problem. That's why I am concluding this is also 5-star problem. Okay. So
GeopByte.